Now, welcome class. Now let's look at tangent lines. A tangent line is to a circle at a point like P. So anything tangent to this line right here. The straight line that touches the circle at just one point. So it touches the circle at just one point. So this is a magnification of it right here. The slope of a curve at point P, the slope of the tangent line to the curve point. So you notice there's different ways to look at this, but it's always this slope right here at these levels, that you have these different points. And it's tangent to that curve. Estimate the slope of a curve at the designated point P. So we need to estimate this slope at this line, at this point P right here. So the slope of a graph at a point is by definition the slope of the tangent line at that point. The figure above shows that the tangent line at P rises 1 unit for each unit change in x. Thus, the slope of the tangent line is at P. So it rises 1 for 1 in this example. So you go up 1, over 1, up 1, over 1. So the slope of this tangent line, of the black line. So the change is going up 1, over 1, that's 1. So the slope of a curve is a rate of change. So the slope of a curve at a point P is that it passes of the tangent line at P. It measures the rate of change of the curve as it passes through that particular point P. Not of the entire curve, but of that point P. So if we interpret this graph, and we could use this for anything, any type of different type of amount spending in healthcare or anything you want to look at. Refer to the figure below to decide whether the following statements about the debt per capita are correct or not. Justify your answers. The debt per capita rose at a faster rate in 1980 than in 2000. So you want to look at the tangency point right here compared to the tangency point right here. You want to look at that slope at just 2000 and 1980. The debt per capita was almost constant up to the mid-1970s. So you see the tangency point, very flat slope, and then rose at an almost constant rate from the 70s to the 80s. So let's look at this. The slope of the graph is marked in red. So let's look at what the graph is. There's the tangency line right there at 1980. Look at it in 2000. You can start to make inferences. In 1980, looks like the slope was much more positive than it was in 2000. And it was much faster. So that's one of the examples how you can look at the rate of change on a graph. So this is an important section on interpreting slope of a graph that will be very important in your ability to look at the rate of change in many different classes that you take or solutions with healthcare data and graphs to look at where maybe spending was more in a particular situation.